Joachim, now you can start.
Okay, so I share the PowerPoint presentation first, and from PowerPoint we go into applications and demo, and you can see the other things. So that is today's webinar. I hope PowerPoint is coming up now.
We cannot see the PowerPoint yet.
Yeah. Yeah. But
oh, something is going on. Okay.
it should be here.
Yes, now we can see your presentation.
Okay, now you see our names, and here the most important internet address for access to all our informations, data sheets, application notes, source codes, and application notes like tutorials and everything we share on our company webpage. By the way, can you see my mouse pointer? Yes, okay. So this is our page for company informations, product informations, overview and everything. And from here we link to our wiki, mostly for the new products, data sheets, application source code. And then we have a subdirectory of our wiki is the forum for question and answers. And we have our European branch office blog, where Tobias and I, and also Felix, from time to time add application demos and something like that. So today's webinar is about a web server. We have built a small embedded module, and also about serial to Ethernet module and serial to Wi-Fi module. And I like to begin with our core chip technology, so you understand why we are able to build very small internet applications modules with only 1 or 2 chips. So what is our company about? It's about connecting everything to the internet. We are a semiconductor company, so we build our own internet connectivity chips, and based on these chips we build modules, but also our customers, you can build your own modules, and you can use the modules to connect everything to the internet. And also we build those wireless modules, very similar approach, serial to Ethernet, serial to Wi-Fi. So it's about internet connectivity. Core technology, here a short comparison between a classic approach you have on your PC, for example, or on embedded PCs like on a Raspberry Pi. You have an operating system like Linux or an embedded operating system, and in that operating system the TCP/IP is processed as a software stack. So there's a lot of code running just to handle TCP/IP data. And only the low end is hardware. That is the Ethernet MAC and PHY layer, where here is the Ethernet cable connected. Our core technology is implementing all those internet protocols in hardware. So these chips are pure silicon gate logic semiconductors, where you can connect your MCU, small application MCU, and this is your interface controller. So here's a more detailed view about that. I have here an example. 4-in-1 SoC we created 2 or 3 years ago, the W7100A, that combine an MCU plus our hardware TCP/IP core plus Ethernet MAC and the Ethernet physical layer in one chip. This is pure silicon, so it's TCP/IP offload. TCP/IP not longer in the MCU, but in hardware. And this makes all internet applications most simple and most secure, most stable. And you can, of course, use any kind of MCU here, not only this 4-in-1 SoC we have, but also our other chips and your own MCU. And you can do it with an operating system or without an operating system. I can show you both later in this presentation. So what we have in our chip portfolio is we have 2-in-1 chips. That is the TCP/IP core. By the way, it has the TCP/IP, UDP, all those protocols implemented on top of the Internet protocol, on top of the Ethernet MAC, so that handshaking and package handling is completely done in this core. This core exists 8 times parallel, and there is a big memory, in this case a 32K RAM, dual ported to support that. So dual ported means that data coming from the microcontroller into that, because you want to send some data into the internet, can be processed exactly the same time in parallel as, for example, on another connectivity data is coming in. Internet is always data in 2 directions at the same time, and the core exists 8 times in parallel, so you can have 8 internet communications at the same time. So chips with 2-in-1 means TCP/IP plus MAC and an MII interface for any kind of media, because this is media independent. So Ethernet PHY or an Ethernet switch for fiber or for any other physical media. Then we have a large family of chips that are these 3-in-1 chips. That is also the focus of today's presentation, where we have integrated the Ethernet PHY already. So you can connect your MCU here by SPI or 8 or 16-bit parallel interface, and you have your small internet application on top here, and just hand over data to send them to the internet. And of course we have chips where an MCU is integrated, so that's a one-chip internet application device. So it's a system on chip. This is an example where we use an operating system, and I want to show you this performance gap from offloading TCP/IP out of the operating system and get a lot of resources free on your MCU. So this is 2 times exactly the same board. It's our evaluation board, the W5300 evaluation board. We ran a small Linux, embedded Linux, and if you use the software stack, then you have a very poor internet performance, or on the other side, a poor MCU performance. The more applications you start, the more occupied is the MCU and can no longer handle internet data, and so the internet throughput drops dramatically. If you make use of hardwired TCP/IP, then the internet performance stays at 70 to 80 megabits per second. We talk here about an 200 megahertz ARM9 MCU, so it's quite a long-term available standard microcontroller, even a little smaller than the Raspberry Pi. So you can see that if you run the Linux, the performance is quite low, and if you make use of hardware TCP/IP, it outperforms everything. And you can start many processes, and you keep the real-time capability on that processes, so that the internet traffic does not disturb the application, and the application does not disturb the internet performance. And here we have another comparison where we say This hardware TCP/IP acts like a firewall. It's a security advantage in parallel to that performance advantage. We compare here our SOC we will release by May. It's the W7500 chip. We have built an AVB for that. In that chip we have a Cortex-M0. So that is the smallest available ARM core you can have. We have implemented 128K of flash memory and 16K of RAM for the MCU, plus that 32K of RAM, dual-ported RAM for the TCP/IP, of course, as mentioned before. And this M0 is running with 48 MHz. And we have made a small demo application, and this is not using any kind of interrupts or so-named operating system. So it's a straightforward firmware. Without operating system, you have an internet application. And for that small application, we occupy just 9K of flash and 9K of RAM. So that is a lot of space left for applications. And we use the Kyle micro C compiler. If we bombard this small MCU with internet traffic and create our own traffic, you can see a high performance. This small M0 is capable of transfer data with 30 to 35 megabit in real time. This is just testing over time, and we flood the network with SYN packages and ARP packages and whatever. So kind of distributed denial of service attack on our interface. If you do the same on a Cortex-M3, a medium-sized 32-bit core with 500K of flash and 64K of RAM, so that's a typical MCU you find for embedded, very small embedded applications. Even this is running with nearly 100 megahertz, and in the application used a small operating system only with a very sophisticated embedded IP stack. We occupy already 64K of flash and 35K of RAM. So it's quite occupied, and performance is like zero. As soon as there is any internet traffic on the Ethernet, every ARP or SYN or whatever ping package comes in here into the MCU, and the core is totally overfloated. And the internet performance of such a device is totally collapsing. As soon as there is traffic, these are only 1,000 packages a second. So this is in a standard LAN network where someone makes a file transfer from one PC to another PC, and you have those embedded application attached to the same network. The MCU is totally occupied, and the network performance drops totally. So you have to take care which traffic goes really on the interface. That is what we say a firewall function by the hardwired TCP/IP core. I will go back 2 slides to show you the TCP core again. So the MCU is on top here. Just access some registers to configure the core, and then the TCP/IP engine process all that data directly. So if there is any package or attack coming from here, it goes into the engine, and this analyzes the packet. And if this is not needed for the application here in your MCU, the data is dropped. So the MCU is not disturbed by any interrupt to check data that is not intended for your application. So all those disturbing traffic is already cut out here in the TCP/IP engine. And only data that is really useful and according to the configuration for your application, that data and only the raw data, the really useful data for your application is stored here in that memory. For your MCU, our chip looked like an external memory with some configuration registers. And so this is the most performing Internet interface for small MCUs. You see that performance here. So we have those products. As I told you, we have this new SOC by May, where we combine our technology from the 5.5 chip, I show you later, also in the web server, with a Cortex-M0 into one silicon chip. And that with this chip, it's already in our laboratory. We did the performance test, so you saw that this chip attached to even a Cortex-M0 is capable of doing a high internet performance. And we use this chip on our I/O, a plug-in module. So here's just the SPI interface. We plug that into your EDB, for example, or your application. Attach some wires to your MCU, use the SPI interface, and you have internet connectivity ready. This chip is also available on an Arduino shield, many Arduino shields for many third-party vendors. We use this chip also on our serial to Ethernet module. Here is an example for another one. We use the 7.1 chip. So we have serial interface to Ethernet interface. And we use that chip also on our web server, and I will show you the web server in a few seconds. And this few seconds is here. This is the web server module where you have a lot of digital I/O, analog, serial interface, a lot more of interfaces. What is on this module? There is here a Cortex-M3. Because we want to do a web server, it's better to have a little bit more performance and a little bit more of memory. So we add a big flash memory on the bottom side of this module, 1 megabyte of flash memory for pictures and HTML files and whatever you want to store. If you want to be more flexible, we have also a micro SD card socket here attached to the MCU. Also here you can store your internet or web server data. And we coded a small application on this Cortex-M3, and we make use of the W5500 chip with Ethernet PHY, MAC, and the TCP/IP engine. So that's the 3-in-1 chip. Of course, connected with an RJ45 for the Ethernet. To say more, yeah. Later in a demo, we want to show you we control remotely, for example, the data out on that pin here, the 0. And if we toggle this pin, we connected it to D11, just random, and then you can immediately see that the level on this pin is toggled, and we can read out the status via web page, because it's a web server, and we can do it also as a machine-to-machine protocol without human interface. It's possible. So this is the evaluation board. You see the same module again. On this evaluation board, we provided the power supply. We have analog and digital I/Os isolated with optocoupler. Also, we have those 4 buttons. So 4 of these 8 I/Os are in parallel occupied by these buttons. You can select with these jumpers. Of course, here is reset button and the boot button. And we have here an analog temperature sensor connected to our module. We have also here potentiometer, analog voltage divider for an analog voltage, and we have 8 isolated digital out with those relays, so you can connect external voltage here and switch those isolated voltages. And serial interface, of course, the 2 UARTs, and we used an RS-232 transceiver to have an access by PC, for example, or RS-485 for a field bus application. And last but not least, of course, the Ethernet interface. Here you see the 5500 chip, W5500. It's a QFP 48-pin package. You see it's just 7 by 7 millimeters, a quite tiny little interface chip, and the 25 megahertz crystal for the Ethernet. And here you have the MCU with the crystal for the MCU to have it clock synchronous on the UARTs. Such MCU provide also internal clock references, but with the crystal you have the best performance on the UARTs. And this slide I want to explain you more about how web servers or TCP/IP connectivity is working. So if we talk about a web server, it's like a telephone call action or an answer machine. There will be a call to connect to the web server, and then the web server is answering, and then there is communication. And what we have here is the status machine inside our hardwired TCP/IP engine that assisted the on-top application web server. So what is happening, or what is the MCU in the application doing, and what is the hardware TCP/IP engine doing? First, we have to initialize some register that is sending or making the chip ready. That is like preparing the telephone, switch it on. You have to configure it. You have to enter your PIN number and then activate the telephone, and then first step of preparation is ready. Then you sitting in front of the telephone and waiting the call. Come. Just boring time, doing nothing, waiting a call to come. That is a status listen. To do this on our internet web server, we only need to configure 2 registers. So it's from the MCU part, it's just access registers, set up some bits, that's it. Then there is data coming from the internet. First there is a SYN package coming, so you can see that on the Wireshark. For example, this is a program to log data in internet. It's one package in the TCP/IP protocol that tells, or that is sent by the client to a server to say, hello, I like to communicate with you, please open one socket. And if the socket is in listen mode, then the socket answer with a SYN acknowledge. That is like pressing the green button and say, hello, I'm Joachim and I like to talk with you. This is completely automatically processed by the hardware TCP/IP engine. So the MCU does not even know about it. Then again, there is an acknowledge because you respond to me. Yes, I have time. I like to talk with you. I'm the SOS, whatever. Now, after these 3 packages going in and out automatically, the TCP/IP socket is going into the established mode. And I told you, in our chip we have 8 of these sockets in parallel. So a web server can be accessed 8 times in parallel by 8 clients. This, in the first idea, this looks limited. But if you recognize, for example, a Raspberry Pi is a 1 gigahertz ARM, is also not able to open more than 10 or 20 sockets at the same time. And the core is overflowing with internet traffic quite soon. So these 8 socket connections is not really a big disadvantage compared to an embedded PC that is 10,000 times bigger. We compare here 50 megahertz ARM0 or ARM3, M3 with 1 gigahertz A8 mobile phone processor. And also such a socket connection is opened and closed very, very quickly. Just a few or only 1 millisecond. Those packages going in and out with below a millisecond. So within a few milliseconds you have a socket established, you can transfer data and you close it. That is very, very quickly. And in most cases you have the 8 sockets in a listen mode more than they are really in an established mode. And once a connection is established, data is transferred and goes into listen back into listen mode, the socket is available for the next client to connect. We tried with a big office to overrun our web server. So even if you use many PCs and open the web page, reload every time, you will never run into a situation that this web server is not available. Again, I told you we talk about a hardware engine. This hardware engine internally is many hundred times faster than your PC you're sitting in front of. It's gate logic. Internally, just some transistor logics making these status changes. This is very, very quick. Okay, once the connection is established, data can be transferred like memcopy. You copy the data you want to send into the internal memory and you give a command, send the data, and if data is coming in, the data is, or the packages are packed and the raw data is in our memory and the MCU can access to that data. That is a very simple read and write process. So I can show you a small TCP server, kind of web server. Here is the main loop, just initializing some UARTs and the chip. And we check the DHCP. Also, this is very simple, checking if the DHCP and then if the DHCP is processed, or we have a static IP. The configuration is finished, and then and then we go into the while loop. And the while loop is not blocking, non-blocking. Means you can add here your real-time data application on top. Just from time to time, we go here into checking status, and if there is something to do, we go to the handler. If not, we're coming out here instantly. So this is not occupying the MCU. You have all the time to do any kind of real-time application. What is happening here? We check from time to time if the HTTP, maybe the lease time is ran out, we need a new IP address. But as we want to be HTTP server, it's better to have a static IP. Anyway, we just go into HTTP server ROM. Go in, check the HTTP status. If there is any connection established and we need to process HTTP data, we do it. If not, the while loop starts from the beginning. Let's have a look into this HTTP server. Looks like this. We have a socket that is initialized first. We have the socket in listen mode, and then we have here the same. This is the main loop here. Again, maybe it's not so good to explain. This while loop is actually this while loop here. You get the socket status. If it's established, you check data is in the buffer. Yes, it has a length bigger than 0. Then we configure here the length information. We read out with receive those buffer informations, and we send an HTTP file, or we send hello world. Just send an answer. We show you this in the real application later. And if a socket is closed, wait here, we close it. If the socket is closed, we make it listen again. we make it socket listen. And then this loop can run again and again and again. And this is made for all the 8 sockets, if you like. So that I here goes from 0 to 7 is the 8 sockets. So maybe I hand over to Tobias and he can. Okay. Okay. On Tobias' PC, the audio, the microphone is not working. I will talk, and Tobias will show you the web server and how to work with it, and then we go also into the source code for a little bit more details. Before we do that, is there any question?
So far, we don't have any questions, so we can continue with Tobias' presentation. And I switch his role so he can start to present it.
You share your desktop, Tobias. Okay, Tobias is now sharing his desktop.
Okay, now we can see Tobias' desktop.
Okay, yes, that's the configuration tool. I just tell you what Tobias is doing. Hopefully I understand everything. So the configuration tool we did in Java. So it's an open source configuration tool. And the module is connected to the Ethernet. Okay, you disconnected your Ethernet interface. No? Okay. Yes. So once you click on the search button, you will have the MAC address here below what is here WizNet. What? Just a few seconds ago, that was working. Okay. Maria, can you share again, make me the presenter, and we will check with Tobias' computer again?
Just a second, please.
Yep.
Okay, now it's your turn.
Okay, I'm on again, so Tobias can check again.
So I can switch back to Tobias?
No, wait a sec.
Okay.
Okay, that is strange. Is it possible that Tobias log out and off the webinar and log in again?
We can try it, but I can see him on my phone.
Okay. Can I share my desktop in the meantime, and I show you these parts from my computer. Just my computer is getting slow. Okay. I don't know. Miri, do you see my desktop?
Yes, I can see it.
Okay. So we have here the configuration tool. If you click on Search, you see the serial to Ethernet module and the web server module. So we have here the web server module with this MAC address. If we look into my presentation, I will show you later. All our modules have a MAC address here. This is actually the web server we have here on our desktop, and there is a MAC address. So on our that's nice. I made it. I clean up a little bit my desktop so that it is not disturbing you. Yeah. So on our web server here we have a MAC address, and this MAC address is shown here, and then you see the configuration. The web server has a static MAC. No, this is DHCP activated. Okay, so our network here internally is the 111. My computer also has a 111 IP address, and the 133, that is the web server just on my right hand side here. What I can do is I copy that IP address into a browser, right? So we use here the browser, copy the MAC address, the IP address, and you have the web server responding. This is not a PC or a server in some server farm at Google or wherever. This is really the Cortex M3 with the W5500 Ethernet interface. So, Tobias, what happened here? I did something I should not do. Device name. Why? What happened here? Something copied in here. That was the name. That is Tobias Well's web server here, and it has the MAC address again. It has the IP address. We have the serial port here, and the second serial port here. And here we have the digital status. And as I told you in my presentation, or I show you the presentation again. Yes, I flicker with some relays. We made this connection between the digital 0 and the digital 11. So if I go to the digital 0 and make the relay on, then the D11 input goes on. And if I click it off, maybe you can hear the noise of the relay if I click on such a button.
No, we cannot.
No, you cannot hear the clicking. But you can see if that I click, and a few milliseconds delay, the input is activated. This demo web server is working with JavaScript. So not only that we have an HTTP file, we have also JavaScript. And so that this page is interactive with these buttons and automatic read out. So in the background there is this TCP IP network traffic to transfer this information and read out or receive in a push action the status update on the inputs. What we also have is we have the analog informations on our analog inputs, the temperature and the potentiometer. So we can turn and tune the potentiometer. It goes up and down. Now we are on one side and we can turn it to the other side. Of course, we can configure the IOs with some alias name for machine-to-machine configuration communication, and we have the serial data. What we can do is just send some data to the serial interface, and we can see and receive serial data. Currently, there is nothing connected, but I show you serial data communication on the serial to Ethernet gateway module in a few minutes later. So, is your PC running again, Tobias? Yeah, I think we can show some parts of the on the GitHub. I can show, if possible, or our blog, and how to customize the web page, how to customize source code. I think. Okay, Miri, maybe you can make Tobias?
Yes, just a second, please.
Sure.
Okay. Now it's Tobias' turn.
Tobias' turn. Okay. If there are any questions, just interrupt us. We just show here our blog first. So here you maybe start with our wiki page first.
Okay, so far we can see anything to be shared.
Your desktop is not shared. Okay. Okay.
Okay,
it
now
should be.
It's in progress. Just a second.
So
yes, now it's okay.
So what you see here is our wiki. So there we have a collection of products and all those informations, data sheets, applications, and we link to source codes. As you can see here already, a link to a GitHub site to have those those materials we share on the GitHub. If we go into the web server, you can see here also in different languages, Korean and Chinese. We have a data sheet and a get you started guide. Here, for example, all pin descriptions. And if you like to code on the MCU yourself, you see that on these pins are multiple functions because the MCU offer not only digital I/O but also SPI, I2C, USB, and other functionalities. You can make use of all the MCU functions. Here the pin description, and some details of the evaluation board, the isolated data out, the relay, and also the optocoupled isolated data in. And maybe you show those downloads. In downloads, a few lines later, down, there. We have linked to binary files, of course, but also to the GitHub. So if you go onto the GitHub repository, you find the update status. We made the web server 1.10 already. If you scroll down a little bit, you see that the stable version we released half a year ago is the 1.01. And if you go and click on the headline, and on the right-hand side you have a download button. You just download a zip file. Then you have all the material, the web page, HTML file plus those icons for the buttons, everything, the web page that is on in the flash memory or on the micro SD card. And in the firmware folder you find the complete source code of this application. And this firmware source code can be used in a development environment, for example, an Eclipse development environment, and it can be used on any kind of C compiler. Here you use the GNU C compiler in the background. So what you can see here is the Eclipse development environment, and we have those. We have directly implemented the GitHub repository into the Eclipse environment, so we can fork and link into these developments here from the Eclipse. And you can do the same. So you are invited, if you like, share our GitHub group and make your own modifications, upload those modifications on GitHub, fork, and make different applications on our web server. To help you to set this up, we created our blog. And Tobias is currently working on a home automation project in his house. He wanted to remotely control lights and doors and windows, and using the KNX bus for that, and the WIS550 web server as interface to connect different sensors and actuators in his house. So he's documenting his project here on our blog. But to do all the customization, he is of course using the Eclipse development environment and is customizing everything. So from here, you see we have those projects linked where we explain how to set up the Eclipse environment. And you can do that, of course, on Windows PCs as well as on Linux PCs. There is no difference here. And here is explained how to upload the new customized firmware onto the STM32 MCU. So there is on the one hand side those programming and coding environment, and on the other side programming the MCU, of course. flash memory. All is explained in our blog. And I think now there might be some questions where we go into details. We have a lot of time, so we can show you more details. What is wrong? Okay. Really? Are you online?
Yes, I'm here.
Yeah. Okay. Any questions?
So far, we don't have any questions.
All right. Then maybe I share my PowerPoint presentation.
Okay, so I switch over to you. Okay, now you should be able to share your PowerPoint.
Okay, let's have a look what we can show you more. I think very quickly we go to the serial to Ethernet applications. Okay, but I want to give you this.
Yeah, we didn't see presentation, but it's already on, so we can.
Okay. In our this wiki, we have this product with 550 web, and of course a page for the configuration tool, and we have pages to explain the evaluation boards, IOs. We have all those pages we showed you. So you can find the Java application, the configuration tool here. In the same wiki, we have a page for all those downloads. Tobias showed you a few seconds ago with link to GitHub. And in the GitHub, you can download the zip files, clone and fork our repository, and become part of our community if you like. And in our blog, we showed you Tobias' home automation project, and with tags like Eclipse, GitHub, or our product names, you quickly find those blog entries that hand you into how to set up everything well. I hope with these information you might have an easy start using the web server, or in the same wiki, of course, we have also the serial to Ethernet and our Wi-Fi products informations linked the same way. And both the wiki and the blog is updated every day, every week, very regularly. So in the next weeks and months and years, there will be a lot more of information. And if there is anything wrong in our wiki, we can update and edit this just instantly. Okay, let's have a look to what we have. We have those network modules that are our chip. Open everything. Our chip on a small PCB and the connector. So these are plug-in modules that enable you and your MCU application to attach a network interface directly. So I speak of a network card for microcontrollers if we talk about those plug-in or I/O modules. Then we have a big family of those serial to Ethernet gateway modules. That could be very small modules, just stamp size plug-in, or even pre-programmed chips, a pre-programmed serial to Ethernet chip. And there are modules like this module or bigger modules with other interfaces to do any kind of serial to Ethernet. Then we have Wi-Fi modules, clients, and access point modules. And we have access point modules here, for example, the web server we showed you just a few seconds ago. And now I like to go to that serial Ethernet gateway functions. It's exactly the same like our web server, but a more reduced MCU, smaller and cheaper modules with 1 or 2 or 4 serial interfaces where you can do serial to Ethernet applications, and we coded those applications long time already, so that these applications are very, very stable. I would say the most stable serial to Ethernet application modules you can find, because there is no operating system, no interrupts. These modules consume just 150 milliamp of power, so there is also no temperature issue. You plug them into an application for home automation or measurement equipment or whatever you have with serial interface, and they are running for decades, years and years and years. You don't need any reset or anything. They just running 24 hours a day, 365 days a year, forever. So what we want to show you today is using these serial to Ethernet module having TTL level outputs on the pins, and we have a baseboard that converts those to an RS-232 or to an RS-485. And also we have those applications for all the other modules, and we use all kinds of MCUs. We have here an 8051 from Core River on this module. We have here our own 8051 core. Here we use the NXP Cortex M0. So you see it's really a tiny little microcontroller. And here on these blue modules we have the Cortex M3 from SD Micro, and we have 2 or even 4 serial interfaces. So these modules are made by one chip here or 2 chips, and have those serial interfaces and of course the Ethernet connectivity. And as I told you, we offer this modules chip here also pre-programmed, so that you have a pre-programmed serial to Ethernet chip. And you only need to add a crystal, a connector, and your application here on the UART side, and you have serial to Ethernet on your application. Let's have a closer look onto our WIS 550 S2E, and I show you also some live working application. It's this module with the serial interface, hardware handshaking, and status pins on one side, and here's some more sophisticated information signals on the other side. And you can add that into your application, and we have those baseboards for here for RS-232. This is a picture we took a few seconds ago here from our desktop. I used here a W5500 EVB, so that is our chip. That is also the NXP M0, and here USB, a serial interface, and here we have those serial Ethernet RS-232 connections, and we can transfer data in any directions you like. Here it's Ethernet connection between those two, but I can also show you Ethernet connectivity or internet connectivity from PC to Internet and back here into the module, out from the serial interface into the PC, coming in here and there. This is just a look at this EVB, only that you know that we have here our chip and the Cortex M0 with only 12K RAM and 96K flash. And there is a real EEPROM in the MCU, where's the here, to store configuration data permanently. So even if there is a power surge, power off, power on, the configuration stays in the module. To make the evaluation board more useful, we have also here the potentiometer and temperature sensor and something like that, and the Arduino compatible connectors here on the outside. And also on an evaluation board, the JTAG or ARM debug interface to make it more suitable to make your own applications. So what can we show you? In the first, I want to show you a very, very tiny Loopback server. That is mostly the thing I showed you before in the presentation already. So it establishes a TCP socket and a UDP socket. You have both options done. And every data that is coming in from the Ethernet side, right here from the Ethernet side coming into the module, is just loopbacked back into the Ethernet. So if I have here a PC, connect Ethernet to our module, I send the data in here, the data is just reflected, sent back to my PC. Parallel to that, I connect with USB here to the serial interface and have a look at the debug messages. What is inside? We have a main loop that is just initializing the SDI interface, because of course the connection between the Cortex M0 and the W55 is SDI here. Then we initialize the chip, we make the network configuration, and then we have a loop. In this loop we check, of course, the network is stable and so on. And we have the loopback of the TCP, and we have a loopback of UDP. And if there is data, it's just sent back. So have a look into the loopback. There is a switch, and in case a socket is established and we have data, there is a if condition if there is data and these sizes are not 0, then we send the same data back. That's all. This application is really small. There is not a lot more of that. Maybe we try again to hand over the presentation to Tobias, and he will show you this loopback scenario.
Okay, just a second, please.
This is not unable.
So now Tobias can present this presentation.
So on the left side, you can see a PuTTY session that is connected to my serial line. So Linux is called PTY USB 0. On Windows, it would be just some COM port. On the right side, you can see a TCP IP connection to the Ethernet side of the module, connected in this case to 192.168.111.222 on port 5000. You can see here. So, as it is a loopback, when we will send data on the Ethernet side, I will just write hello world, and I confirm with the return. Communication was okay. I open the connection again. 192.168.111.222. Yeah, 5000. It's a raw connection. I open the connection. You saw it was confirmed with an connected, and now I send hello world, confirm with return. You see from the from our microcontroller that it said data returned, and in my terminal you saw the answer hello world. So, and again and again and again, A, B, C, and so on. That's the demonstration. I will hand over to Joachim back. So this is the first step to come to a serial to Ethernet application. We will show you the next. Maybe we hand over the presentation to my desktop again. I don't know if this is still viewing with Tobias else's desktop. Miri?
Please, once again, because...
Yeah, I need the PowerPoint presentation on my PC again.
Okay, just
so we need to do that game again 2 times.
Okay. Now you should be able to share it.
Yes.
But I can't see anything.
Yeah, my computer needs 5 seconds for that.
Okay.
Okay, here we are again. So this application was static on the module side. So we configured this Loopback server. There is a static IP, and the PC from Tobias here had an IP address from the DHCP on our local DHCP. So that was the 171. Yeah. And but we made a connection. We transferred data back and forward. And now we make the more interesting application to use our module. So we have the config tool again. So we need to configure the module, and after that we can use the module serial to Ethernet and backward. Data can be transferred in both directions. We can make it both DHCP, both dynamic, but we can also make the serial module static IP. And then we finish this part, and then we have another 10 minutes maybe on Wi-Fi, and I think 11:20 we are ready. Sorry, we have to go back to Tobias.
Yes, please, just a second. Okay.
Yes, I'm sharing the screen. So first I will do a serial connection to my TTY S0. So on Windows this would be just the COM1 with 115,200K serial. I open the connection, so I'm connected to the serial line of the WIS 550 web. I show the config tool first. Sorry, so what is it still running? It's still running. So in the config tool, I can do the search, and here you see the WIS 550 S2E. I see it has this IP address, the 192.168.111.183, and the port forwarding was configured to port 5000, and it's a server, you see here. So on one side I have here the serial connection, and on the other side I will now connect to that port 192.168.111.183 on port 5000. I click on open. So now I have a connection via our module, and when I now send data on this window via the Ethernet ABC and press return, it will show up on my serial side, on my serial interface. This of course also goes back, and so I type back. Yeah, it was directly shown on the serial side. It is sent directly. So as soon as I type something, I get it sent via the serial line. Here is no echo on that putty, but there's not, no big thing. So it's working, and I hand over back to you. Maybe I can point out some more functions we have on this serial to Ethernet module and with the config tool. It's all explained, of course, in the wiki, in the user guide to show you how to use the module, how to use the config tool. The module can also be client, so it will automatically connect to the host IP address. So this could be the IP address of another module that is going in server mode. In mixed mode, both is working in vice versa. So if there is no client, the client cannot connect to the server, but it is a server and the client can connect to the server. So it can be both at the same time. And you can do the same serial to Ethernet without those IP address connectivity with UDP. Just send data to this IP address, to the 183, and this data shows up on the serial side and the other. Then, to keep such a connection alive, especially if you are a client, we have those in activity timer and a reconnectivity time to keep a connection established. For example, sometimes there might be cable plugged off and on again, or a device is moved from one place to another. That doesn't matter. If you say once a second we try a reconnect, then the connection is re-established. Of course, the serial interface needs a configuration on the baud rate. We support 7 and 8-bit. We support odd and even and no parity. We have that 1 and 2 stop bits. We have the flow control, hardware flow control for RS422 bidirectional and RS485 unidirectional control. Then we have a special function that is a T command. If you enable that, you can enter here 3 digits. If we send those 3 digits from the serial side, the module goes into a IT command mode, and we can configure the module with AT commands on the serial side. Then, of course, we can send data in a package. So if serial data pops in, we can say, okay, we want to send data to the internet only if 10 bytes are in a row. Then we have to type 10 bytes, and only with 10 are finished, the data is transferred to the internet. Such functionalities. And we can also protect the setting as well as the connection by password. We can enable DHCP or disable DHCP, then we have static. You see that this is gray now because of DHCP activated. And we have the DNS support. All this is explained in the wiki. Okay, now it's time for Wi-Fi. Same. Any question before that?
We have some questions.
And Miri, you can give me the presentation back.
Okay, so there is one question. Is there any information available for the W7500?
Of course, yes. The 7500 is ready. We have it in production, and we will ship the first parts to Europe in May. So together with evaluation boards that will be ready in May, and the wiki and demo applications will be ready in May. The chip itself is, I can show you just in a few seconds. Share my PowerPoint again.
I had one more question we have.
Yeah.
Okay, so the other question is, can I use VSNet configuration tool for VSP210 module?
Oh yes, but it's a different configuration tool. It looks very similar. So it's the same. You set up the serial setup side and you set up the Wi-Fi side. There is a configuration tool for the 210-220 Wi-Fi module. Yeah. The tool name is Smart Script because it's on the serial side. It's with AT command type of configuration tool. It's not with those buttons but some serial commands. You can just select one after another and you have the same functionality. Back to the shortly. I can show you both in a few seconds. Just want to have my mouse back here. I want to show you the overview. Here currently you have very little information on the 7.5, but there was this page with my chip overview. I think it was before that here. So the 7.5 is also an SIP, like the 7.1. So it's one silicon that has an ARM Cortex-M0. It has the TCP/IP engine and the MAC. And there will be another version with a physical layer implemented. So it is MCU plus TCP/IP plus MAC, and the other one is MCU plus TCP/IP plus MAC plus 5. That is the 7500 chip. The first chip we will publish in May is in a 64-pin QFP package, a QFP 64-pin. And yes, the MCU has 16K of RAM, 128K of flash, plus this 32K for the Ethernet buffer, the dual port RAM. The TCP/IP engine and the buffer is attached to the high-speed internal bus, memory bus. So if we have the look into this picture, the memory as well as the TCP/IP engine is attached to the high-speed data bus. So the core can access to that buffer and the TCP/IP engine with full speed. That's why we have here this 35 megabits of data throughput. And this is even not using direct memory access. We have a DMA engine here, so we can even increase the speed a little bit. But, or let's say we can reduce the core load on processing data from memory to TCP/IP. You can see even without using DMA, we have the 35 megabits data transfer from core memory to hardware TCP/IP and out. This is real application data throughput. This is not just one package rushing by in this speed. This is the is like if you want to play a video or use it, it's going with this speed. What else? We have interfaces: 3 UART, 2 SPI, I2C, analog digital converters. We have a random number generator. We have the direct memory access engine, and we have a lot of GPIO pins. So it's a general purpose 64-pin MCU with a lot of options. And you have to wait just another 4 weeks and everything is published in May. And available in May, so you can place your orders. Okay, just quick go down. Here for the Wi-Fi, we have modules like ASK the 210, 220, and we have the 250 in the client module section, and we have those 630 for the access point with the client. The 610 is obsoleted. I go to the Wi-Fi part of our presentation. So these are the client modules for embedded applications in the industrial temperature range. They have very low power consumption, and you can configure the output power. And we have a config tool, of course. And the modules have an option to be access point also. But then, as it has a serial interface, of course, it's not a router. But if you access, for example, with a smartphone, you can access to the internal web page, you can configure that, or you can access to the serial through Ethernet to serial, of course, access to serial data, and you have your application. So up to 5 clients can connect to the module, maybe doing something on the web page here on the module's internal web page, and one of it can access to the serial interface and make serial to Ethernet. But the standard application for those client modules would be that this is a station, and it will connect to an access point, and you have your MCU attached here, and you can transfer data serial to Ethernet to the server. And yeah, we have those RF data. We have a serial configuration port, and we have a Webserver inside for configuration. So you can configure this config tool on the web page and with serial commands. It's very tiny module, and we offer the module also in a version without these antenna, then using the antenna connector here. This makes it even more small. And there is no operating system. You switch it on, and a few milliseconds later it's on. And on the other side, we have those 600 family Wi-Fi modules that are access points. They are always on. They consume a lot of energy as your router at home. And it has an operating system. It needs 20 seconds for booting. And of course, because this is a lot of power consumption in a small embedded module, the temperature range is more a standard temperature range. It's not an extended industrial. Let's focus on these Wi-Fi 250 serial to Ethernet Wi-Fi module and have a look how to use it. We have those Arduino Shield compatible evaluation board. It's a standalone working, but you can plug it on to an Arduino and have Arduino Wi-Fi. But as a standalone module, you can use it with these buttons and the IOs. And of course, we have the wiki again. So I maybe share my desktop to make that more easy for you to follow. Yeah, again, in the wiki, we have the Wi-Fi 250 section. Maybe I'll make the wiki a little bigger. Is it okay? Yeah, I hope this is more convenient. And the Wi-Fi 250 has all these features. You see, you can have it with the pattern antenna. Actually, is antenna diversity because we have the antenna connector, the UFL connector here, and the module decides which antenna is more capable. And we can cut off this antenna, but we need to retune the network internally, so we offer a second product, the connector version. Then you have the UFL connector here. And as for the evaluation board, we offer the header version. Might be more easy to use with some wires to connect this to your development environment. Then, of course, we have the data sheet, the programming guide, the quick start guide. That will help you a little bit further. The quick start guide explains how to use the evaluation board and how to use the module itself. Or is the wiki? Yeah. So if you plug in the USB cable here, you have the power supply, some LEDs goes on, and this button is for Arduino board use. So if you plug it into an Arduino, you have the reset on top for those. And for standalone use, we have here the function button. And with the function button, you can make a factory default recover. You have to hold it pressed down for about 3 or 4 seconds. If you click it once shortly, then it goes into an access point mode. As I told you, it can be access point for up to 5 clients or 5 stations. And it is a web server. So you can access to the internal web page. For firmware update, there is the over-the-air mode and factory default and recover. Yeah, both. Okay, with factory default, you just reset the setup. With factory recover, if something is broken with the firmware, it makes the standard firmware load the standard firmware again. These are the indication by the LEDs, pin description, and you know how to do that. So if we go to serial to Wi-Fi, maybe first we make it an access point, configure it, and then after that we make it the serial to Wi-Fi module, and we connect to the one side serial, one side Ethernet. So what I want to show you now is how to configure it just by the internal web page. I click the function button once, then there are a few LEDs here flickering, and then this is on. Then you can go into your Wi-Fi setup and you find the Wi-Fi 250 access point with the MAC address. The MAC address is also here printed on the module, and you can connect to it. To connect to the module, this is Wi-Fi connectivity. You need a password, and that is explained. Here, that is the key. 1, 2, 3, 4, 5, 6, 7, 8, 9. Very simple. So if I connect here, I have to enter this 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the module will give my PC an IP address as it acts as an access point as DHCP server. I have any kind of IP address. Let's have a look what I am. On the Wi-Fi interface, I'm the 12.2 here. Is it possible to see that? Yeah. And the module itself is the one, is the gateway. Okay, we go to that web page. Just open the 12.1. So now we have to enter here also passwords for the access to the web page. That's admin. But you can change that if you like. So I log in, and here we have the configuration. So we can click on here some buttons, and we can configure the node of the module. We configure protocol to use. We can go down, make over the air firmware update. We can control some GPIOs. We can get I/O status. So if I manipulate some I/Os, these outputs will change. Or I can also set some outputs here for high, for example, then the LED can go on and off. And of course, we can make the serial setting. And here we can set up the serial interface baud rate. So that is the serial configuration. Now the web server is stopped. The module goes into serial to Ethernet mode. It will connect itself to an access point. It's configured, so it will establish the network environment, and we can access and make serial to Ethernet. More interesting maybe is we have yeah, I think we have done everything. We can connect to it and make serial to Ethernet as before. The presentation is already 1 hour and 30 minutes. Any question or?
Yes, we have one more question.
Mm-hmm.
Should I use any delays during this type 210 in initialization function, or just waiting for response command from this file model?
Wait a second.
It's in the chat. You cannot see it, but I will send you this question, so you can see it in the chat right now.
Yeah, have a look. Because normally those modules, after configuration or everything, they are up and running in a few milliseconds, so you don't need to wait anything. You mean between those initialization functions for the Wi-Fi 210? Is there any wait needed between those commands? No, the serial interface is so slow. After sending a command, before you can send another one, the command is already processed internally. No, there is no delay needed. The delay needed. No. Quick answer. Mm-hmm.
Okay, so I do not have any other question.
Yeah, there was this interesting idea about the external networks. Yes, of course, a web server or any kind of serial to Ethernet application we have here you can access from everywhere from the world. The internet is the global network. So even from the other side of the world, internet packages only need a few milliseconds to go here. There is no visible delay. You can even use 3G or GPRS networks and access to the web server. Of course, yes. There is no limitation. The web server has an IP address, and you can access to the IP address, and that's it. That was live demo here. Maybe we say thanks. Is that visible? We are here the European branch office team, and if you have any questions, you can contact the application engineers and salespeople from SOS Electronics, of course, and us here with sales and with support at wisnet.eu, our email address. And our main homepage and everything is linked from there is wisnet.eu. You're welcome to contact us at any time. Thanks very much.
Okay, so thank you, Joachim and Tobias, for your presentation. I would also like to thank all of you for your time to attend this webinar. As I said at the beginning, after webinar, I will send you offer with a special price for business modules, and you can order it if you're interested. All the instructions will be in email you will receive from me. If there is any question regarding VisNet, and so, as Joachim already said, feel free to contact us or directly VisNet to answer your question. And I just want to thank you for your time and wish you a nice day. And also, I would like to see you at our next webinars, and all the information about next webinars will be on our webpage. And of course, the record from this webinar will be also available at our webpage next week. Yes. So thank you very much, everybody. And
if you have any you want to link or find our product at SOS. SOS created this shortcut page, just SOS Electronics, and then VisNet, and then you have all the VisNet modules and links here. Also, the webinar is again here, the videos, some PDF files for download, and links to here is our webpage embedded, so you can go to our webpage here. So you're welcome to join the VisNet family.
Okay, so thank you one more time, Joachim, Tobias, and thank you everybody for attending this webinar. Have a nice day.
Thank
Bye.
Bye-bye.